Hello, Algebra 2 people. So, our last section of Chapter 3. If you haven't noticed by now, it's all about solving quadratics. You guys have completed the square, you've done factoring, you have done looking at a graph and finding the x or the roots, the x-intercepts from a graph. Now we're looking at when none of those work, you can always use the quadratic formula. So the quadratic formula is what we use when we have our quadratic in standard form and we set it equal to 0. We know that a cannot be 0 because then that would be silly. You wouldn't have a quadratic. And we like to keep a, b, and c as real numbers. And when that's the case, then we can actually solve this. Now I'm going to write the quadratic formula two different ways because I know you guys know and love it as all one fraction. And again, sorry for my voice, but I'm gonna sing it. X equals opposite of b plus or minus radical b squared minus 4ac all over 2a. Yay! Which I know that seems silly, but if you can sing it, you know what? Then you are going to remember it. You could say that about any formula. If you can make a song out of it, you're more likely to remember it. Now that's the form you know, but when I do it, I actually like to write it as two fractions because what I find is when people simplify the quadratic formula, they often only simplify the first terms and forget about the radical term. So I like to break it up into the two fractions. That way you are sure to simplify both of them. Okay, let's put this to use. So here we have an equation and it's set equal to 0. And so we're going to identify our a. Here's our b, here's our c, and I always like to do the b squared minus 4ac first, partly because we're going to talk about what that means. That's actually called the discriminant, and it also is the biggest part of the equation. So if you can just break that down into one number to begin with, it makes using the quadratic equation easier. So b squared is negative 6 squared, which is 36, minus 4 times 1 times 4. So 36 minus 16 is going to be 20. All right, so now we're ready to actually do the whole quadratic. So we have x equals the opposite of b over 2 plus or minus the square root of 20, which we've already figured out. That's our b squared minus 4ac all over 2. So that wasn't so bad. Now we go to simplify it. So 6 over 2 is 3. We have to simplify 20. Remember, 20 is going to be, kind of write it off here to the side. Square root of 20 is the square root of 4 times the square root of 5. So this will come out as 2 rad 5. So I can rewrite this as 2 rad 5 over 2. And of course the 2's cancel. So we are ready to write the final x equals 3 plus or minus rad 5. And that is the first use of your quadratic formula. All right, let's try another one. So we have here that we need to first set this all equal to 0 because that's the first thing. So we're going to subtract 12x from both sides. Plus 4 equals 0. So I have a is 9, b is a negative 12, and c is 4. So when I do b squared minus 4ac, I'm going to have 144, which is 12 squared, negative 12 squared. That'll always be positive because you're squaring it, minus 4 times 9 times 4. And it turns out that that is going to be 144 minus 144, which is going to equal 0. So that's really nice when that happens, because that means I have x equals the opposite of b, 12, over 2 times a, which is 18, minus the square root of 0 over 2 times a, which is 18, and 0 over anything is going to be 0. So the only thing you want to do here is reduce your fraction. So 6 goes into both of these, so this reduces to 2/3. All right, so we've seen when you get a nice positive number, you have a plus or minus. When you have the discriminant being 0, you end up with only opposite of b over 2a. And let's look at this last example. So again, first thing we have to do is set it equal to 0. So x squared plus 8x plus 41 equals 0. So we have a is 1, b is 8, c is 41. So when I go to do my discriminant, I have b squared is 64 minus 4 times 1 times 41. So 64 minus 4 times 41 is 164. So this is going to equal a negative 100. So now we can do our quadratic. So x equals the opposite of b over 2 times a, plus or minus the square root of a negative 100 over 2. That's good. All right, so we can start to simplify. X equals a negative 4 plus or minus. Now this negative 100, remember when you have a negative under the radical, the negative part comes out as I, and the square root of 100 is 10. So this will become 10I divided by 2. So our final answer is negative 4 plus or minus 5I, since we can reduce 10 over 2 to 5. All right, and then when your discriminant is negative, notice you had a complex root. So that's to illustrate how the discriminant works. The discriminant without the radical is just the b squared minus 4ac. And what it does is it tells us what kind of roots we're going to have. And I like to think of it as like a number line. We know that we have negative numbers, we have 0, and then we have positive numbers. So when you do b squared minus 4ac, if you get a negative number, that means you're going to have 2 complex roots. There's going to be an I in your answer. If you get 0, like we did in the middle example, you're only going to have 1 real root. And if you get a positive number, like in our first example, then you have 2 real roots. So let's kind of see again, what does this mean? So if b squared minus 4ac is a negative number, that means 2 complex roots, which means you have I. And as a graph, what that looks like is you never cross the x-axis. So you're either going like this, or maybe you're going downwards. Either way, you never cross the x-axis. On the other hand, if b squared minus 4ac equals 0, that means we have 1 real root. And that's actually, hopefully you recognize that 1 real root was opposite of b over 2a. Remember that represents the vertex, the x-coordinate of a vertex. When that happens, you only have 1 solution, 1 root, because your vertex is sitting on the x-axis. So this x-coordinate would be opposite of b over 2a. And then lastly, if we have b squared minus 4ac greater than 0, you have your 2 real roots, and that means you're going to cross the graph in 2 different places. So you have your root 1 and your root 2. Okay? So that's why it's helpful to kind of know, it gives you an expectation of what type of roots to expect. So let's do these examples down here. For each equation, find the discriminant, describe the number and type of solutions, and then go ahead and solve the quadratic. So it's basically the same process we were just doing. So you're getting some more practice. This would be a good time to pause the video and maybe try a few of these on your own. So here on A, notice everything is a multiple of 4. So I'm actually going to go through and simplify this. Why use bigger numbers if we don't have to? So what happens is this becomes x squared plus 2x plus 1 equals 0. So that means that A is 1, and B is 2, and C is 1. So when I do my B squared minus 4AC, I'm going to get B squared is 2 squared minus 4 times 1 times 1. I get 4 minus 4, which is 0. So my discriminant is the 0. It's that number that you found. And what does that mean? That means I'm going to have one real root. What is that root? It's going to just be x equals opposite of b over 2a in this case, which is going to be negative 2 over 2, which is a negative 1. So x equals negative 1 is our solution. Okay, let's try this next one. We have a is 1/2, b is 1, c is a negative 1. So b squared minus 4ac is going to be 1 minus 4 times 1/2 times a negative 1. That negative 1 is going to make this positive. So I always like to immediately put that negative there so I don't forget to change the sign. So what we have here is 1 plus half of 4, which is 2. That's going to give me 3. And that means we have 2 real roots because that is a positive number. And so then when we go to finish off the whole quadratic, we know that x equals opposite of b over 2 times 1/2 plus or minus the square root of 3, which is nice if you've already figured out that whole b squared minus 4ac. There's your discriminant underneath the radical, over 2 times 1/2, which is 1. So this simplifies, negative 1, this all simplifies to 1. So negative 1 plus or minus rad 3. And that would be our final answer. And then our third example, so think about what we need to do first. Always set your equation equal to 0. I like to keep my a value positive, so I'm going to move everyone over to the side with 5x squared. So this will become minus 8x plus 13. So a now is 5, b is a negative 8, c is 13. So when I do my discriminant, notice I'm not using the radical. The radical is not part of the discriminant. The discriminant is just the portion underneath the radical. So b squared is negative 8 squared. That's 64. Minus 4 times 5 times 13. That's going to be a big number. And I'm going to, so obviously you're going to maybe want to use a calculator. Working that out, I get a negative 196, which means I'm going to have 2 complex solutions or roots. Just so you know, those mean the same thing. So we'll kind of emphasize that. So there's my discriminant. There's what the discriminant means. Now let's find, sorry. Damn it. Okay, I kind of went away for a minute there, so I hope there wasn't a big glitch in this. So I'm just going to keep going. We found in this third example negative 196 for our discriminant, and we're about to then solve this. So we have x equals the opposite of b over 2 times a plus or minus the square root of negative 196 over 2 times a. So I have 8 over 10, which we know can reduce to, put a 4 here, so x equals 4/5 plus or minus 196, well, the negative part, remember, becomes I, and the 196 is the square root of 14, and so we've got here 14I over 10. And I can reduce that a little bit more because these are both even, so this will be a 7 and a 5. Since I have the same denominator, I can write it all together. 4 plus or minus 7I over 5. And that would be what happens when you have a negative discriminant. That's a lot of work right there, okay? Now we've talked a lot about applications in this chapter, and now we're going to look at the full equation. We looked at when you just drop an object from the top of a building. Now we're going to actually toss the object. So an object is tossed in the air, and there's several ways that can be happening. It can be thrown up in the air, it can be spiked down like a volleyball, or it can be shot straight like an arrow coming out of a bow and arrow. And the equation, you've seen the first part of this, the negative 16t squared. Now we're going to add in a velocity component, and then we have our height. So all of these things together, this again represents your height of an object at time t. And then remember, the negative 16 is our gravitational, basically I'm just going to call it gravity, gravitational constant. It's always going to be there. And now we introduce v naught. V naught is your initial velocity. So it's the velocity, again, that little sub-zero means the velocity at time 0. So how hard did you throw the ball or hit the ball or spike the ball? And it can be positive, it can be negative, it can also be 0, depending on whether it's going up, straight down, or straight out, okay? Let's see, what else do we want to talk about? All right, yeah, so here in the examples, the golf ball is initially, it is, let me see if I can find a color you can see, is going up. So here v naught, whatever it is going to be a positive value. If you are initially spiking the ball down, your initial velocity is going to be negative, because velocity is speed with direction. And if you're going straight out, you're not going up or down, believe it or not, your velocity is going to count as a 0. And then gravity will bring the arrow down. All right, so let's look at how these applications work. So we have a juggler who tosses a ball into the air. The ball is going to leave the juggler's hand 4 feet above the ground, and it has an initial velocity of 30 feet per second. So let's first come up with an equation that models that information. So h of t, you'll always have the negative 16t squared. Our initial velocity here is 30, and since it is a juggler tossing the ball into the air, it's a positive 30 times t. And the initial height, that sort of like your y-intercept, how high was your hand when you first release the ball, is 4 feet. So there's our equation. Then it's going to ask us, the juggler catches the ball when it falls back to a height of 3 feet. And it wants to know how long, in other words, what is t when he catches the ball? How long was it in the air? So what we're going to do is we're going to let h of t equal 3, because that's how high the ball is when he catches it. and we set that equal to our equation. So we have a quadratic. These are definitely calculator type problems. And actually, let's take a look at how this would look in a graph. So initially, at 4 feet, the juggler tosses the ball in the air, and it goes up, and then it starts to come down. And when it gets to 3 feet right here, that's when the juggler is going to catch the ball. So he catches it when y or h equals 3. Okay, so let's go ahead and we have a quadratic. What's the first thing you do? You set it equal to 0. So negative 16t squared plus 30t. So we subtracted 3 from both sides so that this becomes 1. We went minus 3, minus 3. Okay? All right, we're going to do the same strategy we did before. A is negative 16. B is 30. C, not t, C is going to be 1. And so I'm going to do the discriminant first. It just makes doing the whole big ugly formula a little bit simpler. So b squared is 30 squared minus 4 times a negative 16, so I'm going to put that negative here to make this middle sign positive, times 1. So we have 900, which is 30 squared, plus 64. So that's going to give me 964. So we're going to have 2 real answers, which makes sense. Notice if you follow this graph all the way down, you will usually get a negative time and a positive time. And that's because the ball, if it hadn't started at 4 feet and just followed it back, you only want the one answer. So you're going to end up having to get rid of that negative answer. But let's start to now plug it in and find our solution. So we have t is opposite of b, plus or minus the square root of 964. And in this one, I'm going to keep it all as one fraction because we really want to get one decimal answer. That's really what we're after. And then 2 times a, which is negative 16. So let's start to just simplify this, and then you can enter it in your calculator. So we have negative 30 plus square root of 964. You'd want to enter that. You would want to then hit enter at the end of that, and then divide it by negative 32, because that's going to give you negative 0.033. And then we take the low row, t also equals negative 30 minus square root of 964. Enter that in your calculator, hit enter, then divided by negative 32, and that is going to give you 1.908 seconds. So there's the 2 answers we have to choose from. So like I said, you'll often get one answer that's negative, and we can throw that one out. So we know that when the ball was 3 feet high, time was 1.908 seconds. All right, so I hope you have fun working with this.